It seems no questions from your end. So shall I proceed for the discussions? Because actually, I got to know the objective of these day schools are basically to answer your questions instead of delivering standard lectures. So it's a nice approach actually, but if you don't have any questions, I would start my discussion as usual. That's why I just want to check initially. If you have any questions, then definitely it's added some value for you. Unless I could be able to continue my discussion as usual. What do you prefer actually? Shall I continue? If you don't have any questions, I can proceed actually. Please let me know if you have any questions quickly.
Yeah, it's better to continue the lectures.
Sorry.
Yeah, it's better to continue the lectures because no one is going to ask the questions here.
All right, then we'll continue our discussion. Now, today, the very first topic that we want to discuss is the probability based methods. Basically, it's all about something related to probabilities and methodologies or some of algorithms on top of these probability. So, what you can hear from the AI or the data science aspect is probability based approaches or probability approaches. There are advantages and disadvantages both under this probability approaches. Under this topic, we are mainly focusing only two aspects. One is knife based, the other one is logistic regression. So we first of all we'll go through some of the core information or related to the discussion. So we'll see what are these probabilistic methods. Actually, these I believe you all learned grade 10, 11, probably 7 even. Probability, what is probability means. But just a quick review. Probability is a measure of likelihood of an event. So simply a coin would flipped head or tail. Right? So there's a probability of having one, right? Or zero, or head or tail. So that's the point, something. We can tell today there's a probability of high in rain. So we are not sure. It's not perfect like coin flipping. Coin flip, we have definitely, there's two options. Very rare option to be like in the middle, but the usual scenario should be head or tail. So most of the time, like weather predictions and accident prediction and some of classification problems, it's really hard to tell perfect probability because the feature set do have large varieties. So somehow this probability is in the measure of to be happen, likelihoodness. Rain, there's a rain to be this, right? And whatever the things in the here and there. Right? So we'll see how these algorithms would support for us. It's basically quantifying the uncertainty by the reasoning of an uncertain event because rain is not sure. We can't give a 100 out of 100 accurately give a probability. So it's just something that we deal with uncertainty. Basically, this is an event to be happen or not. So it's all about 0 to 1. 0 means there's no possibility of having this event, no probability of having this event. 1 means there's a high probability or it's sure it's happening. Right? So for an example, now we are pretty sure sun will arise from east, right? Not from west. So sun will arise from east, probability is 1. Sun will rise from west, probability is 0. In between something can be happen, right? We are not in a certain something that uncertain, we are not sure. So in between 0.5 means 50-50 chance, right? We are purchasing a lottery and there's a 50-50 of chance. So some probability in between 1 to 0, there's nothing at all, or we get the full amount. of the Venus, right? So that kind of a scenario. Somehow these intermediate values are representing various degrees of this likelihoodness. If it is like 0.9, then the probability is extremely high. 0.1 means the probability is extremely low. In other way, we can tell 1 over the 10, yeah, or else 9 over the 10. Right? Simply, you can tell the same thing. This is equals to 0.9. This is equals to 0.1, right? So this is basic mathematics, actually, what you have learned in grade 7, 8, probably. Basic terminology that you should learn. The very first thing is the sample space. It's the possibility of outcomes for an experiment. Once we are doing some of experiment, we could have something, right? We could have some possibility to have in a feature space or some sample space, what we are telling. For an example, if it is 6-sided die, so you know what is this die. So very soon we are playing with these things. The probabilities or the sequences or the actions that could be happen in this case is, we can get number 1, 2, 3, 4, or 5 or 6. So that's the maximum space, sample space that we can find. If it is flipping a coin, the feature space is 0 or 1, because 0 means head or tail, whatever you define, right? We'll tell it's tail, here it's head. There's only 2 feature space we have. Right? So the sample space is always like the maximum number of all the occurrences that we can happen in a given instance. If we can have this kind of discrete sample space, our life is much easier, because we specifically know the sample space. If we have red balls, green balls, and yellow balls, we know specifically how many balls we have. So the sample space can be defined. But the real world scenarios, like for an example, accident prediction or rain prediction, right? Any other cases, the sample space is extremely high based on the number of varieties. So the feature set to deal a lot in this case. So probably you can remember last day school, we learned this feature engineering and stuff. So this is a point that we have to consider. We have to think specifically what kind of feature range we have. An event is something, a subset of sample space representing one or more outcomes. For instance, rolling an even number in the 6th die corresponds to event 2, 4, 6. The feature space or the sample space that we have is 1, 2, 3, 4, 5, 6. Among this sample space, we can have these occurrences in an event. Right? If you ask to have a different story, for an example, odd number, then you can write 1, 3, and 5. These are the events that could be occur for this scenario. Next, we'll go to another key term related to this probability. It's probability, measuring the likelihoodness of an event occurring. It's usually denoted by PE. So this is the standard mathematical equation or mathematical representation that we are telling. E is an event, any event. This is an event, right? Probability of satisfying certain, including non-negatives, because there's no possibility to have a negative value. It should be a positive value, definitely, because any occurrence means there's an action, so there should be something. And the probability of sample space being 1 maximum, that's the being 1 is the story of this maximum story of this sample space. So if we add it all together, the sample space is, so the probability is 1. For an example, if we take a situation, flipping a coin, so 1 over the other one is 1 over the other one, the maximum sample space is connected together. So 1 plus 1, so it's equals to 2 over 2. So answer is 1. Any situation, we can tell 1. If we take the same sample space, this scenario, 1 over 6, right? So 1 means 1 over 6. 2 means again plus 1 over 6. Again 1 over 6 for 3, 1 over 6, 1 over 6, 1 over 6. Once we add it all together, then 6 over 6. So the answer is again 1. So the Probability is maximum. The combine like adding together means the final value is 1. So if we have proper sample space, then our life is much easy. So we can specify these probabilistic ranges easier. Then the distribution, once it comes to this probability distribution, it describes the probabilities of all possible outcomes of a random variable. It might be a discrete or it might be a continuous, uncountable to infinite outcomes or finite or countable. So the story that we have to understand is the probability distributions are like, we can't tell whether it's specifically easy for going for discrete or continuous. It's always depends with the problem. So we have to understand how to continue, how to work with these kinds of a scenario. Actually, I'm not expecting you to go through in a very detailed probability lesson because this is not the time to learn all of these probabilities now. But I'm pretty sure, I'm guaranteed actually, without probability and statistics, you can't dive this subject, this data science properly. So I would strongly encourage you to learn. If you are weak in probability, give couple of hours for your life. Definitely, it's a big advantage for you at the end of the day to understand if you are planning to become a data scientist. Because without probability and statistics, you can't proceed. Like you can proceed applied data science, but once it comes to in detail, it might be extremely complicated for you to understand what is happening behind the scene. So give a try. I just given some of overview related to this probabilities. Once it comes to probability distributions, we have mainly two distribution types. One is discrete distribution. The other one is the continuous distributions. Discrete distributions are representing the probabilities of discrete outcomes. For an example, binomial, Poisson, or Bernoulli distributions. Like for an example, this is a distribution like very strong scenario. Now we'll get a real world scenario. Then you will understand a bit more. We'll get a scenario that here we have school starting, right? We'll get an example, 8 a.m. I don't know what that type now it's starting. We'll assume schools are starting at 8 a.m., right? Sometimes 7:30. So we'll get it's 8 a.m. So number of students attending or passing the gate, right? We are counting 1, 2, 3, 4, 5, 6, 7, 8, likewise up to 500 or something, right? Maximum will take number of students in a given minute. So if we divide into like 7:30, right? 7:30 a.m. Right? 7:30 a.m. 7 a.m. We got the very first student came. So it's 7 o'clock here. It's starting at 7 o'clock. Then 7:30, some of the students, then all of a sudden a big or a huge curve, then it's going very strong. Probably it's not this much even. It's very strong down and it's coming over here. Like 8, 5, 8, 10, like it's too far even for this case. The maximum number of students are almost attended within the next couple of minutes. Like 5, 8, 10, I'll upload it again. Much more easier way. Here you can go. It's going up over there. It's strongly going down and it's like to stopping. Number of students passes, right? So this kind of a curve might be there, but the usual scenario, what we are expecting is a nice curve, right? Or what we are telling a Gaussian or a normal distribution. This is a normal distribution, right? This is not a normal distribution at all. It's bias. It's something push somewhere else. Probably you learn these binomials, position, Poissons and stuff. But I just given a recap for you. These are the basic distribution types. Based on these distribution types, the algorithm that we are going to apply is different. That's all I want to tell you. For an example, the once we are developing an algorithm or once we using an algorithm, the algorithm is expecting the data set should be in a normal distribution, right? So that's the primary assumption kept for that algorithm. Before you apply that algorithm, we should confirm the data set is properly distributed in a Gaussian distribution. If not, you can't apply. right? So what I'm emphasizing this scenario is if we have some certain number of assumptions, and one assumption among these assumptions is before we apply an algorithm, we keep an assumption the data set is in a normal distribution or a Gaussian distribution. Now, if you got a data set with not a normal distribution, it's skewed to somewhere, then you have to think whether I'm going to apply this algorithm or not. If you are planning to apply this algorithm, how to normalize this data set. Before you use this skewed data set, you have to normalize it properly. You have to change to a normal distribution, then you can use. Or else, sometimes another algorithm might be fit for that scenario than this transformation. So I can't specify what is the exact methodology we can apply for this scenario, but whatever the things that fit for this scenario can be applied. So my suggestion, my final conclusion is you should apply as much as algorithms, and you should go through as much as what we call these assumptions before you apply an algorithm. So it's a must, right? It's a must to think what kind of distribution we have. That's why we have this EDA part. We are going for a strong EDA part to understand how the data distribution is. If the data distribution is in Poisson or the binomial, the algorithms might be different. So, or else you have to convert to a normal distribution. Right? So that's the point that I want to emphasize under this case. But I would strongly encourage again, give a bit of effort to understand what are these distributions, how it happens, and so on and so forth, because I'm not sure whether everyone got this information previously or learned in somewhere. If not, no worries at all. Just Google it or go to YouTube or somewhere, ChatGPT or something. Just type what is this binomial distribution is with an examples. Then they'll give. But under this core concepts, the detailed concepts, you have to learn all of these math and stuff. But initially, my general suggestion is go with a simple thing. Then you go to much complicated things. Right. So that's the story of these distributions. We'll come to the story of this logistic regression. Now we understood the probability and probability distributions and stuff. Now we have an algorithm called logistic regression. It's a simple binary classification problem or binary classification algorithm. It's not a regression actually, right? Though the name mentioned it's a regression, we don't have a specific regression line as it is. It's basically to convert into two types. Right? So it's a statistical model that we can use for our work, right? So it's basically telling the probability of having a scenario, probability of having a situation in somewhere. In somewhere, we are not, we can't give a guaranteed where is it happening. Somewhere it's happening, right? So that's the point that we have to understand where is it is going. Unlike the linear regression, the predicting continuous outcomes. This is the difference. Like continuous outcomes, logistic regression predicts probability that an instance belongs to particular category. I'll give a real world example, then you can understand a bit more. I want to classify into two types, right? For an example, I will post an activity also in your post page soon. If you go to Kaggle, you can find task or an activity called survival prediction, binary classification problem. There's a Titanic data set that you can apply, and we can tell whether survived or not. Right? So it's basically dividing into two parts. Right? We are telling converting into two parts, right? So again, I'll explain. Now we have two scenarios. One scenario is survived, right? Survived. The people not survived. People not survived. We have survived people and not survived people. If you have a data set and if you want to predict whether this person is survived or not, then you can use logistic regression. I'll ask the same question again. We have a data set and we have done all of these algorithmic implementations. We want to convert, or we want to tell whether this is hate speech or not. So it's dividing into two parts, right? So the ultimate solution lays definitely on top of two things. One is it's a hate speech, the other one is non-hate speech. We want to categorize or classify into two parts. In such scenarios, the best fit is the logistic regression. Do you want any other examples? We'll get any other example. We want to get fruit is a ripe fruit or not. So the problem is to classify into two. A given fruit is ripe. If it is ripe, we can plot over this place. Right? It's ripe. It's not ripe. So ultimate scenario is we want to convert into divide into two parts of our data set. So we convert the data set into two parts. It should be not like perfect line like this. Sometimes it might be like a bit longer. So ultimate scenario is different, like ultimate curve might be different, but you can go for testing and something can be happen. If I ask a question, a flight might delay or not. So again, what you have to do is you have to apply logistic regression. It's logistic regression means classifying is the best solution or the best question. Problem comes to your head, you should think what is the best algorithm. Now the problem is to convert or classify into two parts. So the logistic regression is somewhat best, right? I can't tell according to the data set. Sometimes another algorithm might behave well, but logistic regression is your primary selection. If someone is asking to classify into two, my primary effort is to go for logistic regression and check whether this logistic regression would be able to solve it or not. Actually, behind the scene, there are a lot math and stuff, but I'm not discussing all of these things. It might be a big hassle at the end of the day, but I just want to give the overall idea what happens in here, right? Not with math and stuff, but to get some understanding what happens in this case. So basically, logistic regression is one of best solutions to convert into two possible outcomes. One is something positively happens, the other one is not survived or not, rain or not, right? Hate speech or not, cyberbullying or not, whatever, right? A given text is contain something related to bad words and stuff. So we can classify. The classification process or classification can handle through this logistic regression. I will post the link in the Kaggle competition, so you can go through and get your hands dirty rather than this learning. As I'm always telling, I will post many in future, so you can go through and experiment all of these things. By experimenting, you will learn. By learning theories, you can get the idea what happens, but doing the work, actual coding, then you will realize, this is happening in here, and you will get the hands-on experience at the end of the day, right? It's used often used for the classification and predictive analytics. Basically, one of best solution for this. General applications, medical research to find a disease or not. Right, this person is suffering from this disease or not, or this medicine is allergy for this person or not, or this chemical is react with these blood cells or not, right? Marketing, we want to find a person. This person might be a person that one of our customers or not. Based on some of features, we are telling this person might be a customer for us or not, right? Based on features like what the question's asking, whatever XYZ facts we can analyze and see. You can go through a bit more. I have given a standard logistic regression link actually, but it's for reading again. But if you go to YouTube or ChatGPT or any other place, you can learn thousands of millions of things, right? So something like conventionally, I have added this link for your slides to learn a bit more. Next, we'll go to naive Bayes. Naive Bayes is another interesting topic, which is based on probability distributions. And it's giving again a very strong output using many features. It's based on the Bayes theorem, and primary assumption is independence between the features. Now, if we have feature one, I'll draw a couple of features in here, right? We have feature one, you know this feature space now, feature one, feature two, feature three, and blah, 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 blah things we have, right? So feature 1 and feature 2 are independent from one to another one. Simply you can't add it to a graph. If it is a graph, then there is a dependency. So probabilistic distribution based on the naive Bayesians are like, I can't specifically tell it's, we can't add to a graph, but what I want to emphasize this case is the primary assumption is features are independent. Features are not connected with the other one. So if we take this feature out, there is no effect with any other feature in the given data set. I believe you got it. So in case if you got a question with connected or dependent with one over the other one, then please do not apply NAV-based algorithms in that cases. You will get into a big problem. It might predict actually in real world scenario. If you apply it, they'll give something, right? Even I have tested whether it's not giving or stuck. No, there's no, right? There is no nothing at all. But as a human, you should feed correct data. That's the core concept, right? We learn in day 2 probably. We learn garbage in, garbage out. We have to think whether we are pushing correct data or whether we are feeding correct data for this algorithm or not. So you are the person who knows this data is independent or not. If you fed data whether it's independent or not, it gives some output. That's the reality, right? So you have to think, you have to analyze, you have to do proper EDA part to understand whether the data set is the features are independent in this data set or not. It's must, right? So it's a must to understand. If not, at the end of the day, your predictions and all of these things might be into big trouble. Despite its simplicit assumption, right? Naive-Bayes assumptions, the presence of particular feature in class independent of the presence of feature. This is the simplistic assumption. It simplifies the computation with the classic. Right? Naive-Bayes often performs well in practical, especially text classification, spam filtering, and stuff. Now, once it comes to spam filtering, it's a binary problem, right? A spam or not. Now at a glance you if I ask a question, we want to we got an email, so we want to classify it to two parts. One is it's a spam or not. It's a binary classification problem. Initially it's a binary classification problem. At a glance you can understand, so your hands will go definitely to uh, logistic regression than naive Bayes. That's why I told I can't specifically tell which algorithms perform well. Now, in this case, if we are telling the spam filtering is much stronger in naive Bayes, though it's the binary classification problem happens like the usual, the usual hands goes to this logistic regression, but once it comes to spam filtering or classification, naive Bayes performing well. That's why I'm telling it's all about your testing. You have to test couple of algorithms in the same vector. Then only you can tell, okay, for this problem, this could be the best. Sometimes once it narrow down to many aspects, something differently happen. Right? So somehow theoretically you should understand what happens in this naive Bayesian scenario. There are large varieties of naive-Bayes classifiers. We have Gaussian naive-Bayes, multinomial, and Bernoulli naive-Bayes. So you have to go through and see what kind of scenarios. Actually, the assumptions are different, and the application logics are slightly different from one to another one. So though we are telling naive-Bayes classifier as it is, once it comes to implementation or actual scenario, actual applications, so we have to use Gaussian, multinomial, Bernoulli naive-Bayes according to the question and according to data that we have. So you have to clearly understand what is the most appropriate Bayesian algorithm that we can apply for a given scenario. Bernoulli naive Bayes is actually calculates the proportion of the correct classifier instances out of the total instances in the data set. Right? We can see it's much more related to the others too, right? Basically, this accuracy is something that we are predicting. I believe you learn these things, how to test all of these things, right? How to test what happens in this scenario and how to work with these kinds of scenarios. Somehow, my general suggestion is, though we have like a lot of things like Gaussian, multinomial, and Bernoulli, and plus blah 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 things, generally go to Bernoulli. I believe it could be like, if someone asks narrow down the scope, then my suggestion is go to knife Gaussian or Bernoulli. It might be much easier for you. These are some examples that given for testing purposes of all of these things, but it could be applicable for every Bayesian algorithm, or basically for all the algorithms, right? Accuracy is the total number of predictions and the total number of corrected predictions. And precision, it measures the proportion of the true positives predicted among all the positive predictions, right? So accuracy and precision are key values. Though your algorithm do have very high accuracy, if the precision is low, you have to think twice, because there's something gone wrong. These are some strategic scenarios that you might face in your examination or somewhere. You have to like think very deeply what happens, this accuracy, precision, F1 score, and recall, right? Recall is basically measuring the proportion of the true positives predicting among all actual positives. Now you can see once it comes to this precision and recall, right? We have true positives in both places, right? We have true positives in here. The difference is true positives, and here false negatives are coming to this context. So be careful whether you are going for precision, recall, accuracy. So you should know what kind of differences we have and what kind of differences we can apply throughout this scenario. F1 is just the harmonic mean of the precision, the recall. So basically we add it and multiply with each other. So by calculating this precision and recall, we can have precision plus recall over precision multiplied by recall multiplied by 2 is equals to F1 score. Now, I'm not specifying it's just for Bernoulli, but it could be any Bayesian algorithm, or if we take in a very high, it could be for anything, right? It could be anything at the end of the day. All right, I believe I gone a bit faster pace, but somehow I believe you got something. Any questions, guys? Right. No questions. All good. Last day school practice lab sessions recordings. Oh, recordings are not uploaded. What can I do for now, guys? To be honest, I don't know when I'll get all of these access and stuff. What I can do, the simplest thing is I'll upload to YouTube and I'll add the link to the post page. Then I'll upload to your drive later on. Whatever, whenever I got the stuff, sometimes it might take some time. So till then we don't want to wait, so I'll upload. I think I uploaded and shared the day school 2. I'll add day school 3 and this one also probably, then you can go through and learn. Actually, to be honest, guys, this is a very strong summary, right? It's like very strong summary for this context, if not like for even for Bernoulli. Sorry, if we take Bernoulli, not just Bernoulli, if we take just Naive Bayesian, it might take around 3 to 4 hours for a complete explanation. So probably you have to go through and understand a bit more some of the key points only I'm explaining in this day schools actually, right? So I believe you are fit for this context. I'm a bit new, guys, to be honest, to do like to pressure out you with these 2 hours with lot of context. Sometimes you are familiar and you are okay. For me, it's a bit hard, because from conventional universities to here open, you have some some differences for this teaching and stuff. Somehow, I believe you are okay and manageable. All right. If you don't have any questions, I'll wrap up these probabilistic distributions for now. We'll go to the next topic quickly and we'll start discussion. So the next topic that I want to discuss is clustering. Sometimes you learn classification in your day one, if I'm not mistaken. So today we are going to discuss clustering. Under the clustering, we are focusing mainly k-means and hierarchical clustering. Actually, these are very interesting topics to deal Z and experience and get do all of these things. So we'll see what is this clustering and what happens in this clustering aspect and so on and so forth, right? Yes, the objective of this discussion is you should be able to understand the concepts of clustering and importance in the data science and the data analysis, because clustering is extremely important. To be honest, it's very important because if we take some data set, clustering would plays a big role. Definitely, clustering would plays a big role. And we have to understand the difference between this claim-means clustering and hierarchical clustering. Basically, clustering wise even we have different kinds of categories and we have different kinds of aspects. Right? So we'll discuss those things and I will give some activities also in your course page later on. And next objective is evaluate and performance evaluation of these clustering techniques, because we have numerous clustering techniques applicable for different kinds of scenarios. Since we are not sure what is the extract or what is the most strongest solution for this kind of a problem, whatever the problem, this means you can fill with that whatever the then you have to think where I'm going to apply, what algorithm fits for this case, what kind of algorithm is fit for this case. Next, we'll go for a quick introduction to the clustering. Clustering is a fundamental technique in the field of data analysis, machine learning, AI, and all blah, 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 blah things to uncover hidden patterns or the structures within a data set. Now, once it comes to this pattern recognition, it's a different story. I don't mess up with these things. Pattern recognition, pattern mining, we have a different story. Clustering is a different story. Classification is another different story, right? So these are different aspects in same data science aspect. So don't mess up your life with clustering, classification, mining, right? Pattern recognition, pattern mining, the text classification, text mining. We have numerous parts that discuss, but those are discussing in different aspects. The same scenario, sometimes we discuss in a different aspect. So clearly understand, this is not pattern mining, or this is not classification. This is clustering, right? Unlike supervised learning, where the data is labeled and algorithms are trained to predict specific outcomes. That means once it comes to supervised learning, we have specific outcomes. We expect to have this output, as we already learned. Once it comes to this supervised learning, we have feature set over there. Then we have a specific output, right? We know feature 1 to feature n specifically, we know the feature space specifically, we know what is this feature is age, gender, or whatever the features, we know the labels are given, and the output or the predicted or the expected label also with us. So once it comes to supervised learning, it's much easy, as I told you, because that's the specific outcome we are expecting. But once it comes to clustering, the story is different because we don't have column of the feature names. So the feature space is unrecognized. It's just some data we have. So it's basically unsupervised learning. That means we are dealing with unlabeled or without labels. We have feature 1, feature 2, feature 3, and feature n at the end of the day. And we have something in the data set. What we are going to do is we are going to seek the similarities in the data sets, and we are going to cluster them to 1, 2, and 3 or 5 Z's, whatever. It's based on the characteristics and the attributes. I'll start this discussion with a very simple example. Now, what I'm going to do is I'm going to collect set of data. Now, assume, right, though I'm telling these feature names, you got a data set with feature 1, feature 2, feature 3, and stuff. We'll see, you have this table or a feature space in here, right? We have feature 1, right? Feature 2, feature 3, and some of the features also there, right? Feature 1, feature 2, feature 3, and stuff is in there. Large set of data here. Now I'm the original person who collected the data, so I know the features because I collected the data, right? I know the person, whatever the feature data is, but I'm not giving the data for you. The features given for you, but since I want to explain the scenario, I'm telling the features. Clearly understand, guys. What I'm going to do is I'm going to collect human data, right? I'm going to collect human data. What I'm going to do is I'm going to take 3 features from a human. One is the skin color, right? Skin color. The other one is hair color, right? Hair color, skin color, hair color, and we'll get another feature. We have shape of eyes, right? Shape of eyes, right? Shape of eyes. Skin color, what we are doing is we are getting RGB values. I believe you know these things. I am not sure whether you learn these things or not properly. Hue, saturation are also there. Alpha and stuff also there. Red, green, blue, hue, saturation, and alpha. Finally, we have a value 0.6 or something. I don't know, right? I'm just giving a value 0.6, right? 0.6. What we are going to do, we are taking 1 million of people, right? 1 million of people. That 1 million consists different continents in the world. African people, Chinese people, Sri Lankan people, Europe people, right? Australians, and I don't know. From me, we have skin data. Skin data in the sense we collected these red, green, blue, and hue, saturation, and alpha values at the end of the day, and we combine all of these things. Finally, we have a value called 0.6. 0.6 for black people, black skins, and sorry, we take 0.9 for black skins, 0.1 for fair skins, and like something like brownish people, 0.5 and stuff. Got it? That's the very first feature that we collected, but I'm not giving that information for you. What I'm going to do is I'm going to store that feature values in here. Feature 1 is 0.6, 0.8, 0.9, 0.2, 0.1, and blah, 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 blah values are here. Got it? The very first feature field, but I'm not telling what is this feature is. I know this feature as the original data collector, but I'm not giving the feature for you. Number 2, what I'm going to do is I'm collecting the hair color data again. Again, what I'm going to do is same 1 million people I'm getting. Again, I am going to take these RGB values, hue, saturation, and alpha values. Again, what I can do is I can tell skin color is this, right? Skin color is this, and 0.6, 0.5, 0.8, 0.1, 101, sorry, 0.8, 0.2, and blah, blah, blah values are there. Then the eye shape, we are telling we have nice eye shapes in the globally, the small shapes like big eyes, right? Different kinds of there. Somehow we calculated perimeter and all of these things, and we calculated, we got a value 0 point something, right? We don't know, I don't know actually what kind of things we have. We have some values here, 0 0.8, 0 0.6, 0 0.1, and blah 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 blah. I'm feeding that data to the algorithm, and I'm asking to classify these people. This means we have how many data in here? The data, the feature spaces, the data spaces, we have 1 million. Right? We have 1 million data in here. Now what I'm asking this algorithm, based on these features, you need to classify into 2 types, right? 2 types. Then what this algorithm does, it takes the distances among these features and creates a feature space, a combination of feature space. Then algorithm is telling, all right, these are the set of people like this, these are the set of people like this, and it classifies into 2, cluster into 2. Again, I'm asking, I want to cluster into 3. What you can do? Yes, of course, I can cluster into 3 based on these features. 4, 5, 6, 7, likewise, we can cluster out. According to your thinking, if I ask to classify into two, the most prominent output should be what? Can someone give an answer? What could be the most prominent output? What could be the output that we can think at the end of the day to classify? I have European people, Asian people, and Australian and Africans. Skin color is Africans like bit dark, head hair color dark. Again, Europeans are different. Skin color is fair and hair color also fair. Asians, we have not too fair, not too black, no, not too dark, right? So that kind of features set in your head, right? Almost you have. Now, if I ask to classify into 2 from your question, now if I'm not feeding to the algorithm, I'm just asking from you. If I am into cluster to 2, like 1 million into 2 specifically, what kind of things that you will do at the end of the day? How you cluster out these people? Only using these 3 features. It seems you didn't get the question. Right. Now, somehow, fine. My question is, guys, right? My question is, I'm so sorry, I'm running really fast. Sometimes that might be the reason, because I have only 1 hour to cover all of these things. We'll see, right? Somehow, guys, that's fine. Now, I have 1 million data in here, right? 1 million humans are taken into as my sample. Among this 1 million, I have different kinds of people. Asians are there. We'll narrow down the scope. Asians, Europeans, and Africans, right? We have 3 continents in this scenario. We specifically know that among these 1 million, some people might be Europeans, some of the people might be Asians, some of the people might be Africans. Now, I'm asking you to cluster out to 3 clusters. Right? I'm asking to divide these 1 million people into 3 parts. How you are going to cluster or divide these people into 3 parts? That's my question. I want to cluster out into 3. We have answer cluster into groups based on similar features? Yes, of course. We have to cluster groups based on the similar features. What are the features that you are selecting? That's my question is. Now we have three features over here. We have three features: hair color, skin color, and shape of the eye. What is the prominent feature that you are selecting? It's really complicated, right? Is that so? Yes, good, right? Uh, it's based on skin color. Yes, some of the students are telling yes, you can use skin color as the prominent feature, or else yes, some of the students are telling hair color. Yes, of course, right? Yes, eye shape also important. Got it, right? So now we are in a trouble because we are feeding to a computer, so the computer should understand what could be the most important factor among these factors, right? So as a human you are in a big trouble now. If I ask what is the prominent feature, now we are in a problem, but computer is not actually. Why? These clustering algorithms are super strong to understand the similarities in the data points. It can easily see the distributions and it can easily take what is the most prominent feature among these three based on the data that we fit. Clearly understand, guys, based on the feature that we fit. Why I have these based on, sorry, based on the data that we fit. Why I'm emphasizing, assume among these 1 million, we have only 3 Asians, right? We have only 3 Asians, so 2 Asians. 1 million minus 2 is altogether Europe's and the Europeans and the Africans. We'll take this problem much more into a very strong, into much more problem. We have only 2 Europeans in this data set. So 1 million data set we have. Among this 1 million, only 2 Asians, 2 Europeans. So remaining is Africans. Right? So computer can understand that too, or these clustering algorithms can understand that too easily, right? So it understand all of these things. How? Based on these feature differences, right? It could understand, but please understand, guys, if you are feeding that kind of a data, probabilities of getting into a trouble is very high because we are telling to cluster into three. What could be happen? Asians would be clustered, sorry, Africans could be clustered into three based on their features. I'm not sure whether you got it or not, right? What this algorithm does, it's not clustering the Europeans and Asians and the Africans. Instead, it would cluster Africans based on their features. And it would add these Europeans and Asians where it's very near or near similarities representing in that feature set. Do you got it? What happens in this case? If we have equal partitions, equally we have three clusters, right? For an example, we have 3 million people. Among these 3 million, 1 million people from Asians, 1 million people from Africans, 1 million from Europe, right? So 1 million Europes we have. Then we fed the data, then computer would do, these algorithms would definitely analyze and check where these algorithms are, where these problems are. Then finally it would say, all right, this is the these are the Europeans, these are the Africans, these are the Asians based on the skin color, hair color, and the eye shape, right? The shape of the eye. Now we'll get an example. We'll take this problem into much more complicated. Now assume we have fed that 1 million people, right? These are assumptions, right? We fed 1 million Asians, and among these 1 million Asians, they all have this nice golden hair, similar to Europeans. We have different kinds of coloring and other stuff somehow, right? And we have some countries that usually they have this nice golden color hair. Now what this algorithm is thinking, the algorithm is thinking Europeans and Asians do have similar hair. So don't call out to the algorithm. The issue is the clustered based on the features that we have given. Clearly understand, guys. It would understand, or it would cluster out based on the features that we fed. So if we have selected inappropriate or incorrect population or the sample, then algorithm would definitely provide something bad output for us. Right? I have taken some examples to understand what is going on here and there, and what kind of issues that you might face in future. Right? These are the some general real world experiences that you will get definitely, because data set is biased. Data set do have different kinds of biasness. So it's not properly divided into different kinds of classes, and data collection issues, right? Different kinds of issues might be occur. So you should be vigilant, you should be wise to handle these data sets clearly. It's very interesting, very hard, right? Very hard, very interesting. Right. I believe you got what is clustering, what are the common aspects that we have to think once it comes to clustering, right? Sometimes clustering, because we are not feeding the feature, we do not know the output, right? Some common question that are coming from audience is why we should not features, right? If we add the features, then supervised algorithms are the best, because unsupervised algorithms do not need these labels at all. It's just doing mathematical equations, because it's that's the common action or the common scenario that happens throughout the scenarios. So it's a must to understand clearly where I'm going to apply these supervised learning, unsupervised learning algorithms, and blah 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 things. Clustering endeavors to partitioning a data set into subsets or the clusters where data points within the same cluster are more similar to each other than they are to data points in the other clusters. So what we are going to do is we are clustered out based on different features. Now, I'll draw the same scenario again to explain this a bit more. Since we have three features, we have to come up with three graphs. Please don't come up with a one single graph and tell everything in a one single graph. This is the output. Yes, of course, that's the final output should be. But initially, what we can do is we can cluster out separately. What I'm going to do is I'm going to take the people here, then the skin color, right? Skin color, and sum of dots here, right? Sum of dots here, sum of dots here, and sorry. And we have sum of dots here, something very higher values, sum of dots here, right? And sum of dots here, right? So sum of dots. Now you can see specifically, these are the three clusters. Since you can visualize, your eyes are there, you can understand. But computer, there's no eyes, right? So what it does, it calculates the distances and find what is the most nearest node for me. What is the most mean nearest, or how to take my cluster into ground. I can partition, or I can cluster into any number of clusters. If I want to cluster into two, though we have these three partitions already, we can divide into two. This part is part A, this part is part B, and we have two clusters. If we want 4, 5, 6, 7, 8, 9, 10, yes, of course, we can do that too. right? If you want much more partitions of the clusters, what we can do is we can partition, I don't know, I'm just randomly drawing these partitions, guys. Right? These are the partitions that I have created. Cluster 1, cluster 2, cluster 3, 4, 5, and 6. We have 6 clusters in this case. If we want 16 clusters, 25 clusters, yes, of course, we can cluster out. There is no hard and fast rule. This is the best cluster that we can do. But in the latter part, we'll see best how to find most appropriate or the most strongest clustering, or the number of clusters for a given scenario. Somehow I want to tell, we can have these number of features, feature 1, feature 2, feature 3, feature 4, 5, and stuff. For each and every feature, we are clustering. Then finally, we combine all of these graphs and we have one single graph. Then what we can do is, if we have 3 features, when we have to add 3 different colors. This is red, green, and blue. So we have red dots in this screen, blue dots here, and green dots too. Red, green, blue, all 3 dots are here. Now, according to that, we want to see what kind of clusters we can classify, cluster out. Best clustering is something that feature space that we have to understand where we are going to, right? It's all about clustering into 2. Now the total data set is clustering out to 2. Total data set is clustering into 3 and plus. Here we haven't clustered the total data set. We total data set in the sense total feature set, right? Here we have clustered. Here we have clustered based on the skin color. This is clustered based on hair color. This is clustered based on the eye shape. Right? So we clustered into different places, different things in different ways. And finally, we combine. Now this graph consists all these: skin color, hair color, and eye shape. All these data are in here. Now, if we clustered this graph, that means the total feature space, the total data set we are clustered out. I believe you got it. Do you have any questions, guys? What is this clustering means? What is this clustering means? Any questions quickly before we proceed? Manageable? Understood what is happening in this scenario? No questions? If I ask a question like this, now you learn classification, right? Classification. And you learn clustering now. What is the difference? What is the difference between classification and clustering? These are the very strongest points that we have to think once it comes to this data science. People would definitely like go here and there and do whatever things and blah, 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 blah things. What is the difference between this classification and clustering? These are 2 different techniques. So you have to clearly understand, this is one of major points that I found many students getting messed up their life. Classification and clustering. Yes, quickly. I read couple of answers. We have 48 students, at least 80 students, sorry, 8 students. Engage, guys, unless it's sleepy day, sleepy evening. Yes, I got one answer. We train model for classification. We train the model for classification, but not for clustering. No, that is incorrect, right? we train the model for classification. No, both classification and clustering, we train models, right? We train the train models. We have another answer. Clustering is unsupervised. Yes, a good attempt. Clustering is unsupervised. Yes, right? Yes, clustering is unsupervised learning type. Yes. So then classification is supervised learning technique, right? So that's one difference. So one key point we have to understand. Yes. Anything else? I got two answers. Give your answers, guys. Then you know whether you are correct or incorrect even. I got only two answers. What happens to the others? Quick, guys, quick. I got another answer. Classification groups of predefined blood clustering patterns. Yes. Right. Yes, it's acceptable. Right. Yes. Basically, we have predefined categories. Right. We have what we call this the goal or the objective of this categorizing data is predefined classes or the categories. What are the features that we have defined, right? And these categories we have specifically labeled data. That's why we are telling this supervised, right? Once it comes to clustering, we are not focusing such kind of thing, right? Clustering, we are not focusing on that. We just go through and find the similar data points and we group together these similarities. Yes, that's a good effort. Classification is more complex than clustering. A bit complex to tell whether it's true or false. It depends on the data set and it depends on the problem that we are solving. So we can't tell classification is more complex than clustering. We can't tell. It's based on the data set that we are dealing with. It's based on different kinds of features. Numerous reasons might be there. So it's a bit hard to tell what is hard, right? What is hard to solve, because it might be computationally depends. Sometimes if it is a very small data set, clustering might be easy. Sometimes it might be classification. And if we are focusing on very complicated problems, sometimes clustering is much easier than classification. We can't specify. So that answer is incorrect. Sometimes the same question in your paper. What is the difference between classification and clustering? So you have to prepare for these kinds of practical scenarios. Yes, good. I got another answer. It seems only a couple of students are alive, others are not. Clustering will cluster out data using calculations where data will be grouped based on the values. Grouping, yes. Right, given instructions because it's supervised. Yes, that's a good effort. Classification requires label data. Yes, fine. Right, because it's a supervised learning algorithm. Clustering identify natural grouping data set. Classification assigns predefined. Yes, of course, that's a good effort even. Something other than that, very complicated story. Somehow, I will add couple of articles, guys. And I'll mention some of the things to mandatory, some of the things optional. Optional means you can skip it. There's no questions from these optional things. It's up to you to do or not. If you are doing, it's for you. Mandatory things means those are evaluating in your final examination. So you have to read those things. Read those things means if it is an article, you have to learn the article throughout, not some part. You have to understand the whole story very well. We have another answer. It's the same thing. I think now couple of people are in that's right somehow good. I believe you got the story a bit more. You can understand what is this clustering means. Because by learning this clustering and classification, many people get interrupted. Oh, clustering and classification. Oh, what is this stuff, right? Right. The primary goal is to identify inherent similarities and differences within the data, thereby enabling meaningful insights and facilitating downstream analysis and decision-making process. We are dividing into clusters. We are dividing into set of people, very rich people, very poor people, right? Or else it might be moderate level, very good students or very high intelligent people, students, very low intelligent, very poor students, very lazy students, very engaging students. Right? It's like cluster out. We can cluster into different clusters. We are clustering in many aspects, even in real world scenarios. We are clustering that. We cluster based on the race, religion, and all of these things. Somehow, all of these things are basically to cluster you. You are in this cluster. If you take universities, you are clustered out. You are an entity in open university. That's your cluster. That's your cluster. Some other cluster might be different. Someone from Morato, someone from Japur, someone from Peradini, someone from Jaffna. Different clusters. They have different features. Different features they have. You all have one set of features. They have different features. All of these people, all of us, we have different features. Religion wise, we regional clustering. Some of the people Buddhist, some of them are Muslims, some of Hindus. I don't know whether it's religion. Yes, it's a religion, right? So we all of these things, religions, race. I don't know whether race, right? No, I don't know. Somehow races. We have Sinhala, Tamil, and I don't know, right? We have different kinds of races. So based on the key feature that we cluster out, you are speaking. Your mother tongue is Tamil, so you are a Tamil guy. So you are speaking in English, so you are an Englishman. So you are speaking in Sinhala, you are a Sinhala. You cluster out based on a feature, and multiple features are supporting for the same story. So it seems you are an African. At a glance, we haven't spoke with that guy, but it seems someone from Australia. Right? Now it's really hard to find Australians or Sri Lankans because all Sri Lankans we have nearly very good number of, not all, nearly very good people in Australia living in Australia. They are citizens there, so it's really hard to cluster out, right? Australians and Sri Lankan Australians. Somehow we come to an interesting part. Different types of clustering algorithms. We have partitioning based algorithms like k-means. We have hierarchical electrometric clustering. Basically, it's different. Partitioning means we take into different kinds of partitions. This is hierarchical clustering is a different aspect. Likewise, we have different aspects to be discussed, but we scope down into these partition based algorithms and hierarchical clustering for your subject. But as I'm always advising you, don't stop with that, because real world problems are not scoped down. We don't know what happens at the end of the day. What kind of question is firing for you? You have to prepare yourself for anything. I can scope down, or I can narrow down for the examination, but not for the real life. Real life scenarios, we have no idea how many, how much detail, how many number of algorithms and stuff will be fit for your case. Right, somehow theoretically we'll understand partitioning based algorithms. We have hierarchical clustering, we have density based algorithms. For an example, DBSCAN. This is a very popular algorithm again, to do our day-to-day life. And distribution based clusterings, we have Gaussian mixture models and blah 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 things. Lot of things we have. Grid based clustering we have, and we have lot of algorithms like model based algorithms, right? So it's all about like number of types we have. Under this type, any given type, lot of algorithms too. These are the types: partitioning based, hierarchical clustering, density based clustering. All of these are different kinds of types. Each type contain multiple algorithms. So what we are going to do is we are going to apply an algorithm. Before we are applying the algorithm, if we take the data set, if we can find whether this problem could solve using a partitioning based algorithm, then we can go for selection of set of partition based algorithms. So the partition based implementations, then hierarchical clustering. That's why I'm always emphasizing it's all about the question that we are, or the problem that we are getting. If our problem is to classify or cluster out or divide set of customers based on different features, then yes, of course, you can go for partition based and hierarchical clustering too, right? Both, but the best fit is different, right? Its best fit is different. If we understand, if we take all the people and divide into two, divide into two, divide into two, divide into two likewise, and eventually we can have clustering. Yes, of course, we can go for hierarchical clustering. If it is like partition based on the features, then we can go for partition based algorithms. It's just partition, but like dividing into different parts. Similarly, we can go for distribution based algorithms, grid based algorithms, model based algorithms, and many other algorithms. It depends on the problem that we are handling, problem and the data set. That's the core point that you need to understand. Fuzzy, right? Fuzzy is another interesting bit. Sometimes it be complicated, right? But you can go through. Somehow, clustering algorithms again, real world scenarios you highly used, or if I'm not mistaken, more than 75% of time we are using k-means hierarchical clustering algorithms. DBSCAN, very popular, mean shift, again an interesting algorithm for our work, but I'm not discussing everything. I'm just discussing two algorithms to discuss your work. What are the general applications? We have pattern recognition. We can understand what kind of patterns we have. Again, this is the point that you people, or some of students might getting confused with this pattern recognition and the clustering or classification and stuff. These are different ways, right? Market segmentation. We are segmenting a customer. We are segmenting a business vector. We are segmenting the profitability profiles. Right? So different kinds of segmentations we have. We are applying these segmentations to our work at the end of the day to get succeed. We'll discuss real world implementations. Two implementations I'm going to discuss. One is k-means clustering, right? Very popular algorithm. K-means algorithm is very popular in partitions data into coherent clusters. It's one of very powerful unsupervised learning algorithm to understand the clusters. We have limitations, yes, of course, and we have assumptions and blah 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 things. I will share, guys, a couple of articles with you. Then you can go and refer. Probably you have downloaded and learning some of books and other materials too. If it is not, let me know, then I can share some of interesting things with you. But since I got to know many students are working students, sometimes it might be a bit complicated for your life. But if you can spend some time, I'm pretty sure then you can get interesting things to your life. Understanding the underlying principles of this k-means is interesting. I believe you learn KNN, K nearest neighbor. This is k-means. Those are two different algorithms. Probably Dr. Menaka discussed KNN with you because I got to know that section. So I will upload the rest of the things. Right? So I'm still in a way that working with these chapters and stuff. So the sort of the sections and stuff. We'll see what we can do quickly. I'll upload as much as I can. Basically, once it comes to these clusters, we have to understand the clusteroids, right? Sorry, centroids. Centroids means center of that data set. We have some of clusters, right? This is the cluster and this is the center. This is the cluster and this is the center. This is the cluster and this is the center. Now, this centroids are changing based on number of clusters that we defining. If we have 5 clusters, then we have 5 centroids. If we have 2 clusters, then we have 2 centroids. And it might be laid somewhere else, like here and here. 2 centroids. If we have 5 centroids, then outputs are different. We have 3 here, 4, 5, and 6. These are the centroids because we want to cluster out to 5, right? We want to cluster out to 5. Then we are clustering into 5 set of 5 clusters. So that's the point that you need to understand. So the centroids plays a wider role throughout this clustering process. What is the general procedure or the equation or the action happens behind the scene? It could be nice if you have some of math background. If not, that's fine. You can understand easily. I'll explain in a very simple terms to understand what we are going to do in here. Initially, we choose number of clusters. That means K that you want to partition into the data set to be partitioned. Initially, we have k equals to 1, k equals to 2, k equals to 3, and so on and so forth. If k is equals to 1, right, k is equals to 1, what happens? This is kind of an exam question. K is equals to 1. Now, in our k-means algorithms, we are assigning k equals to 1. Comment on that. Critically evaluate this statement. K equals 1. Guys, quick. Give me an answer. K equals 1. Well, I got an answer 0. No. K equals 1. That means number of clusters equals to 1. That means K equals to 1 means we have how many partitions, guys? One partition. Perfect. One partition means the data set is as it is. There's no partitions at all. Got it? No partitions at all. So by defining k equals to 1, is there any value? No. Right? No value at all, k equals to 1. If we have much more, k equals 2, 3, 4, 5, then something we have. Then we have to deal with all of these XYZ facts. Got it? Right. If you found something else, please let us know. Then we'll discuss in detail how to handle, because some of the scenarios we have niche cases that k equals 1 plays something, right? Something. So research on these fields, right? Some very niche cases we have k equals to 1 gives some value. Right. Initially, what we have to do is we have to initialize the k value, randomly initialize the k clusters with the centroids. Initially, we don't know. So we have k equals to 3. So we define 3 centroids in that data set. We have this data set. I'll visualize it. We have a big data set, k equals to 3. I have defined k equals to 3. Right. Then initially the data set is here. This is one data, all of these places. Right. All these places we have data. I change the color, and here you can see I have 3 random dots, 1, 2, and 3. These are 3 random places that I have defined as my centroids. Then what I'm going to do is, for each data point, assign it to the nearest cluster centroid based on the distance metric. Usually we are using Euclidean distance. Sometimes we have to use Manhattan and other distances also, but we'll take Euclidean distance to make our life easy. So what I'm going to do is I'm going to draw a 90 degrees for these dots. And I'm going to check, right? I'm going to check all of these distances for each and every dot. Each and every dot is getting 1 point, except these centroids, right? If we have 30 dots or 30 data in here, each centroid is linking with each and every, like we have, for this is the centroid A. Centroid A is connecting with all these 30. Centroid B is connecting with all these 30. We have C, right? C centroid also connecting with all these 30 dots or 30 points. Then finding nearest cluster centroid, right? Then finding, now we have one link here, one dot here. We'll assume this is my alpha dot, right? For the alpha dot, how many links we have? 1, 2, and 3. And we have distances. We'll take this is L1, this is L2, right? And this is L3, right? So the distances for alpha to B is L3, alpha to C it's L2, alpha to A it's L1. So if the output is L1 is smaller than L3, smaller than L2, right? What is the cluster that alpha data should be stored, or what is the cluster that we can put this or enter this at this alpha uh, data point? A, B, or C. L1 is the smallest, L3 is second, L3, sorry, here it's L2. L2 is the largest. Under which cluster this alpha point belongs to? A, B, or C? I got one answer. Very good. Thank you. It's correct. Very good. I got 3 answers. Good. Correct. 2 answers. Correct. All right, everyone got it, right? So thank you. Everyone got the story. I haven't received any incorrect answer. So the answer is A. The reason behind L1 is the smallest. So the nearest centroid is A. So what we have to do is we have to consider alpha is in A's cluster, right? So good. Right, that part also done. Now we'll go a bit ahead and see what happens next. Update the step. What we have to do is we have to recalculate the centroids by taking mean of all the data points assigned to each cluster. Now what we are going to do is we are going to calculate the mean of all data points assigned to the each cluster. By calculating, we have a mean value for all of these things. Repeat the assignment and update the steps iteratively until the convergence criteria are met. That means, for an example, centroids do not change significantly or the maximum number of iterations is reached. If we have very high mean value, sometimes by considering into another cluster, it could be the minimum mean, right? So we have to consider what adjustments are now. Distance wise, it's smaller and larger and stuff, but we have to consider the means also. Then we are going to do is we are finding what is the best output for this scenario, what is the best solution for this scenario. So that's this convergence story is going on. I believe you got very high level overview, but I believe its essentials are covered. You understood up to some extent what this scenario is. If not, I'll share some additional resources also to go through. Right, we have testing methods or the performance testing methods. We have elbow method, we have cap statistics, we have within cluster sum of squares, we have number of indexes, right? You have to go through and understand, guys. I'm not discussing in class all of these scores and indexes in this class, but I'm going to discuss the most prominent method, the elbow method, in class. What happens this now initially I told we can't find what is the most correct k value. Instead of that, what we can do is we can tell what is the best k value or most appropriate k for this scenario. What we have to do is we have to start from k equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No number of k is going to change. Then what we are going to do is we are mapping this, plotting this cluster sum within the cluster sum of squares against the number of clusters. Now you can see the number of clusters, the value of k or the clusters, number of clusters here. Clusters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the sum of squared values we have. Then what we are going to do is we are going to connect all of these dots, right? Once we connected, we can find a place that drastically change the graph, right? Yeah, sometimes some of the people are telling elbow method, some of the people are telling knee method, right? Knee method, k level, right? So different kinds of names might be there. Somehow there is a turning point in our data set that it converts to another level. Here you can see a big or a nice curve, and all of a sudden it's going. Right? But so that's the point that we have to understand, and we have to tell 3 is the most optimal k for this scenario. So must to understand, guys, to interpret this kind of a graph and tell what is the most optimal k for this this kind of a activity or scenario. Next, we'll quickly go to hierarchical clustering. What happens in this hierarchical clustering is, guys, we have an algorithm. What we are doing is based on the similar data points, we clustered based on the similarities again. But what we are doing is we are not partitioning, we are dividing, like we are taking a hierarchy. Now you can see this is a hierarchy, right? This is a hierarchy. So this is a hierarchy. It goes from here to, like, by combining these two, we can find this one. By combining all of these and this and stuff, then we can find this one. It's a hierarchical cluster. It's dividing the people or the data into different levels based on the using a hierarchical method. It's hierarchical. It's different between a partitioning method. In partitioning method, we calculate the partitions, number of partitions, 3 partitions, 4 partitions and stuff. But in this case, in the hierarchical structure, we are using a tree structured algorithm, and we are drawing this kind of dendrogram for our illustration purposes to understand what happens in this case. So now you can easily understand, right, the partitioning is giving something else, but tree structure or the tree structured hierarchical clustering, we have another aspect, right? So what are the key features in this kind of a scenario? Here we have bottom up or the top down approaches. We'll take an example of this scenario. What is this? Bottom up approach means in the data point initially represents a single cluster, and the algorithm iteratively merges the most similar clusters until the data points belongs to a single cluster. What we are going is we are going to bottom up. Initially, we have large number of different people in the world, different customers. We'll get an example. And what we are going to do is we are taking similarities among these people, and we are connecting these customers into different kinds of clusters, and we find some similarities among these people too. We combine these people, and we found this one and this one do have some similarities, and we found this similarity, these people are different. And eventually what we are going to do is we are connecting all of these people, right, all of these people to a one single cluster, and this cluster contains all the people, right? If we take x is equals to sum of all of these values. That's the based on. We starting from smaller pieces, and we combine one upper levels, then up, one up, likewise. Within finally we are doing the calculations. We are connecting all of these people into one single place. The top down or the revision method approach is different. What we are going to do is we are having a large set of data in here, right? Here we have a large set of data. Now we are dividing into smaller pieces, right? Smaller pieces into our work. Then what we are going to do is we are having different kinds of similarities, dissimilarities. Based on these dissimilarities, we are classifying, the clustering the people into different classes. So we have eventually divided into smaller pieces at the end of the day. Initially, we have large set, then we have a smaller set at the end of the day. That's how this clustering is going on. Some of basic applications of hierarchical clustering, most of the cases we have marketing, social network analysis. Marketing, we are segmenting the customers, very rich customers, very poor customers, daily customers, random customers, and so on and so forth. And we have social network analysis. We are identifying different kinds of communities, groups, and other different kinds of social networks. And we are trying to elaborate, and we are trying to explain what hierarchy is in this person is, right? Gender wise, age wise, and many features might be there at the end of the day. Some of advantages that we have, actually we does not require number of clusters to be specified in advance. If we take partitioning based, we have to tell number of partitions that we require to go through. For an example, k we have to define, but in this case we don't want to define the number of clusters that we want initially, but it specified once it comes to this derivation method. Bottom up or top down methods are going on. It provides the hierarchical structure that can be useful for understanding relationship between different kinds of clusters. And one of the disadvantages of this scenario is actually computationally intensive, especially for larger data sets. Assume we have 1 million data set and we want to draw a datagram for that. So it's a big story at the end of the day to represent this scenario. And it's lack of scalable, because the algorithm's complexity is definitely like drastically increasing with the number of data points. If we have large number of data points, so the final output is extremely high. Sensitivity to noise and the outliers, specifically the effect of the cluster results. It's really complicated at the end of the day if we have a very large data set. Right, guys, any questions quickly? I have to do another 2 topics. Quickly ask any question if you have. Yes, guys, any questions? It seems no questions. Right. Then we'll start. There's a question asking transformers. Actually, it's a bit complicated here for now, but you drop me an email with these kinds of topics. If you are interested, then we'll do something. I have to discuss how to handle these kinds of scenarios for your case. We'll see, right? We'll see what we can do, because if we start this transforming, it's a big story, right? It's a big story to discuss. Right. I think in data science, as a data scientist, you are dealing with someone else's data. Number one, keep in mind, you don't like to share all of your data with someone else, because you have some privacy, right? So you are interested in your privacy. So as a data scientist, you are responsible for someone else's privacy too. So you could not breach someone else's privacy. That means you store, process, or do whatever things you should do in a appreciated or approved way. Ethics in data science is very important, right? So whatever the things that you are breaching with someone else, these policies and stuff, it could be ends with a big problem. So whenever you are doing these data driven decisions, you have to check whether my customer or the person who is getting this data is approved by himself or herself or not. It's a must. Some of key points that I want to explain specifically: privacy and the consent. So we have to get the privacy, right? So we have to think what the people like to give. For an example, if you are using Google Maps or something, they are asking, we are collecting your data whether you like or not. If you don't like, you can say no. If you want to share the data, yes, of course you can. That data they are collected and they are getting the decisions. Similarly, medicine, right? Any factor, any business vector that you are working, it's essential to understand privacy and getting the approval or the consent from someone else before you store someone else data, before you process someone else data. If they are okay, yes, of course. Some of the people are okay with by removing pill. Pill means personal identifiable information. Then it's anonymized, so we can't find who is the actual person is. There are arguments actually worldwide. We can't specifically narrow down. No one can use your data, right? If you go to your Facebook profile, we can get your name, email address, your friend list, and all of these things. But what Facebook is giving is, they are giving some privacy settings. If you don't like to share your profile picture, no need, block it. If you don't want to share your friends with the other friends, block it. That's fine. That's the point that we are telling. So it's all about a privacy, right? Transparency and accountability. So we have to be transparent how we are going to take the data, what we are going to do with data, what are the sources that we are going to analyze, how we are going to analyze, whether it's breaching someone else's privacy or not, right? So recently I got to know, I got to know there is a data collection for CCTV cameras, right? And even Sri Lankan sell Sri Lankan their personal CCTV camera details. The problem is sometimes your image also in their database now, right? Without any consent, they solve your data, and and there are people who are doing all of these things too. So it's a bit complicated, right? So don't do these kinds of things. If you are a data scientist, check whether these end users or the people, the data that we collected is authorized or not. Please don't go for any unauthorized data collections. Get approvals, whether they like or not. If they like, yes, of course, you can go and check. Fairness and bias. Data scientists must strive to mitigate the biasness in their data and algorithms to fair and equitable outcomes. This includes addressing biasness in the data collection process as well as algorithmic decision making. Once it comes to this biasness, sometimes we bias for some set of people, ethnicity, religion, race, or whatever things. Sometimes, if it is a machinery data or some personal data, what kind of things, sometimes we might be biased. Sometimes we are not fair, right? So what we have to do is we have to be fair in every edge to make sure the data is collected and processed in a fair way. And data security, it's your responsibility to protect data. Make sure to not to leak your collected data to somewhere else without their consents. If they are okay, yes, of course, you can share the data in publicly. If not, please do not share your collected data, because sometimes they have given the approval for you to test and learn and all of these things, but not for someone else. In such scenarios, it might be a big problem at the end of the day. Right. Professionalism and the responsibility. So it's your very professional and responsible person to someone else data. So you are working with someone else data, so you have to understand what kind of ethical guidance or the guidelines that we have to go through in this organization. For example, some of the research work, we have to go for ethical clearance process. We have to check whether we are doing any ethically it's okay or not. There are committees to check, is there any ethical issues raising in this case, especially once it comes to your research work. You have to go for a ethical approval process, and you have to confirm there's no data is collected without anyone's consent, and without consents analyzed, or we haven't given any output. So it's a must to go through with these ethical clearance processes, whatever things that you are going to do at the end of the day. And continuous learning and reflection, this learning in this data science is complex and evolving, because number of sensors, number of machineries, number of devices collecting your data, though you like or not, your mobile phone, your CCTV camera, everything, right? Your device, right? Everything is collecting. So everything is collecting it for marketing perspectives and many other perspectives. So you should be understand what kind of aspects that you should focus on to get the most important things. Right. I have a question. I'll post this question in the post page. You can go through and share some answers with me, probably 3 pages, a simple report. I'll share these things. No marks will be added, not mandatory. So that means don't use ChatGPT and give an answer. If it is point form, yes, of course. If it is written form, yes, of course. If it is a detailed report, yes, of course. The range is up to you. If you have much more time, experiment, learn for you. These are self-study, self-evaluation questions for you. Any questions, guys? Quickly. No questions, all good. Okay, we are doing the last presentation. Actually, this is a practical scenario that is Tableau, right? This is a very strong product for a data analysis, not for a data scientist, actually. Nowadays, even data scientists are using Tableau a lot, but primary objective is to go through with this data analysis work. Objective is to understand the basics of the Tableau and importance of the data visualization. Usually, like in a couple of years back, we mainly focus only data visualizing. We can create large number of different kinds of visualizations, but nowadays it's AI powered. So, and it has a lot of features even, right? So you can do a lot. You can create visualizations. You can take decisions making processes too, right? So basically, It's a powerful and widely used data visualization software. It allows to create interactive shareable. So it's mostly cloud hosted. You can go to and you can create dashboards, reports, and we can connect many data sources, and we can do different kinds of analysis, right? Understand data sets easily by visualization, and we can tell it's very user friendly interface we have. So actually, this is a very practical story. So I have given a couple of links for you. First one is the Tableau software. You download it, you can use it for a while, your free trial. Your desktop version you can download, and you can go for cloud version too. And Tableau, they provides a YouTube channel, separate YouTube channel. You can go through with that and see what kind of actions that we can do. By doing only you will get this experience, not by just learning these things. So I have created an activity for you. Data sets and stuff is given here. I post all of these things in your course page, so you can go through and you can understand all of these activities. I have given a guidance for you, right? How to do. First import the stuff, then calculate these things, then design the dashboards and plus blah 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 things. Then I will create a place to upload all of these things too. So this is for you guys, actually, what I'm telling always. This is for you, not for me. If you have done, it's up to you, right? It's yours work, yours life, yours effort, yours marks, and all of these things. I just given very high level overview to this Tableau, so you can go through and learn a bit more. Sorry, I think you don't have much time to this question and answering, but that's fine. Now we can spend a couple of minutes to discuss if you have any questions, guys. Any questions you have? um, Legal actions. The question is, as an individual, can we get legal actions when some company using data for their purposes in Sri Lanka? You have to check whether you have given the consent to them or not to store the data or process data. And you have to check whether the data is actually your data is used or not. You have to confirm, because if it is a legal case, you have to come up with the evidences, right? Then you can go for and tell these kinds of privacy breaching is going on, so I'm going to escalate in law. But the problem is, soon as they understood, they delete all your personal data. That's all. Then they are telling no data in your case in an organizational level. So that's the story. It's really hard to tackle all of these things, right? Really hard, because if it is deleted, there are a lot of methods to tell, like you can burn it forever. You can't find the data was there or not. Because sometimes if it is in a hard disk, they'll crush the hard disk as it is. That's all. No one can prove there's your data. Really hard to tackle. Any other questions, guys? Yes, I'll upload slides and video. And I'll add some additional activities also. Do those things for you, right? For the most part, if it is like I'll mention mandatory reading, mandatory videos and stuff, then you have to go. It's a must, because it's question. There's the score. If not, some of the things I'm telling not mandatory, or I haven't telling anything. I'm not telling anything, so you can go and learn. Recommended books are in the course page, if I'm not mistaken, because Dr. Menaka told she recommended some books. I believe it's in course page. Please check. Recommended books might be there. Any other questions, guys? All good. So this could be your last day school, right? You have only 4 day schools. I think we have covered all day schools, and if I'm not mistaken, there is another consultation session or something. Sure, actually, something in there in future, so you'll get to know later on those things, right? And Kirushika will do the lab session in future, in the next Sunday probably. Right. If you do have any questions, guys, drop an email, send me a message in in LMS. I'm happy to help you. Like subject wise, I can help you a bit more, not a bit, a lot more. If you need any suggestions, anything, you can drop to me, message me. That's fine. I'm happy to get your feedbacks, your whatever things, right? Your thoughts and stuff, because I can't change the structure, guys. We have to do these things in a given very limited time, in a given day schools, so we can't change it. We have to keep it as it is. But if you have something else additionally to be added, this could be like, this might be best or something, uh, then it could be helpful for my future lessons too, right? So I can if I can adjust my life, right? uh, I'll upload the day school 3 records and stuff also, guys. Soon I'll upload, most probably tomorrow morning, because just after this one, I have another lecture. And not a lecture, I have another like discussion with another guy. So tomorrow it might goes up to midnight. So then after tomorrow morning, early in the morning, our first task is to upload, because I don't want to mess my two things. Is I have to be very formal in there. So I have to do that also. So we'll see, right? So tomorrow morning, definitely I'll upload all of these things. And I'll share these links with you. So you can download it from YouTube probably. Then you can learn from there. All right. Seems no question, suggestion, explanations, maybe some slides just like yeah, actually we'll see. Right, thanks. We'll add much more visuals and stuff. Yeah, I'm planning to add some such kind of things. Thanks, because that makes your life easy. Then you can understand a bit more than just text and words that I'm speaking here. Right, guys. Okay, then I think that's all for this subject. We'll meet soon. Good luck and do your work very well. See you. Bye bye. We'll meet soon.